You're listening to Machine Learning That Works, a podcast hosted by Neptune AI. Hi, I'm Jakub Czakon, Senior Data Scientist at Neptune AI, and today I will be talking to Pawel Godula. Pawel is Director of Customer Analytics at Deepsense.ai, and we will be talking about how he got to where he is, and what you, me, and everyone else can learn from it. Without further ado, my interview with Pawel Godula. Tell me, what you've been doing lately, and at Deepsense, and before.
So at Deepsense, I am a director of customer analytics, and we do projects related to forecasting in the area of customer behavior. So, for example, forecasting if a customer will repay his credit or not, or forecasting what kind of product should we recommend to this client, or forecasting the value of this client to see if it makes sense to reach out to her at all. So this kind of stuff mostly related to the area of customers.
So that's the team you're working with. Mostly folks are doing a lot of tabular data, tabular modeling.
The data that we work with is typically has the shape of events, because this is typically the data that is collected online. For example, from e-commerce websites, you have events. Then from these events, you do feature engineering, you build some features, then you build some models. You build your own time series as well.
And so you, when you're working, on those projects, you are working on. There's a bunch of different sub teams. Like, how large is the team that is working on those? Is
typically the most efficient size for a machine learning or artificial intelligence team I find is between 5 to 10 people. So with 5 to 10 people, you can easily tackle most important aspects of a typical AI project. With more people, it becomes difficult to manage. You lose focus. There's a lot of communication cost. So 5 to 10 projects, 5 to 10 people to me is like the optimal size of a team for a single project, of course, because if you have many projects, that you need to scale across projects. But for one project, 5 to 10 people. And when I talk, for example, to other people in the AI industry, even like very large companies that have their core modeling delivering a lot of value, their core modeling team is around 5 to 10 people. So 5 to 10 people for a single task should be always enough to solve it.
Yeah, like I've seen that as well. Like they divide it usually into smaller features, and there's a team for each feature. There could be some platform team or something like that connects all those dots or all of those things together. But but that I think is is quite a typical scenario in teams that are performing. So you said anything particularly interesting right now in terms of those forecasting projects that you're working on that you want to share?
So right now we are working on a project for a global ad network. It is a project very difficult in terms of production, because we need to deliver 5 million forecasts, 5 million point forecasts per second within like 100 milliseconds latency. So it's a very difficult project, because if you imagine like a global ad network, many people coming, and for every potential customer, you have a set of other products that you can recommend, and actually the resulting the amount of forecasts that we need to do is the product of the number of customers and the number of possible products that we can recommend. So the resulting number is huge, and it's like every second, and it needs to be delivered in it's online basically, so below 100 milliseconds. So it's a very difficult project in terms of production. So it actually taught me a lot in terms of how to productionize large-scale forecasting systems. Couple of maybe not so intuitive moves that we did, but moves that improved a lot the performance of the model. For example, we went from one big light GBM model to 20 small light GBM models.
Large and small, as in large is predicting 20 classes and a small is predicting 2 classes or something, or what do you mean?
Large model is 500 trees and small models are 50 trees. Okay. Basically. And those models, they differ basically by the different data that was used to training or by different random seed even. So actually the problem that we are facing required us to kind of stabilize the results, and averaging predictions across 20 models is much better than taking one prediction from one big model. Because when you are averaging predictions from 20 models, what you can also do is look at the standard deviations of those predictions. So if all models vote positively for a given product, it means you should show it to the customer. If like 5 models vote positively, 15 models vote negatively, then you have a problem. So actually, we take advantage of ensembling, and it was one of the
So wait, let me stop you here. So what you're saying is on this huge data set where you need very low latency, you're ensembling 20 models.
Exactly, and that's why I'm saying it's not intuitive. So in such a production scenario, you would typically expect the model to be like as simple as possible.
Exactly. Yeah.
And that is not so intuitive. I would say it's very counterintuitive. In the production setting, ensembling is much more important than, for example, in competitions. So typically people claim that for those big winning solutions in competitions, they use a lot of ensembling, but you would never use it in real life. I claim in real life, ensembling is much more important than in competitions because of a very simple reason. You get a lot of non-stationarity in real life, something you don't experience in competitions. And in non-stationarity circumstances, actually having diverse group of models helps a lot. Even though given the amount of data and the amount of predictions, we were actually spending a couple $100,000 on Amazon every month. But still, we decided to move from one model to 20 models because the performance improvement was so big.
Yeah, it is an unpopular opinion, and especially for you, knowing sort of both sides of the spectrum. You said, you mentioned competitions. You are very active kegler, right? You had some success just a few weeks ago, right?
Yeah, I won my first solo gold medal. Congrats. That was a dream come true. Thank you so much. So actually I came to data science and to machine learning and to artificial intelligence from the side of competitions. So I started competing and then I realized it is such a great area to be in, and an area that can have like tremendous impact on our lives. So I decided to basically change my life entirely and start coding, start doing data science, start doing machine learning.
So let's talk a bit more about that. So what did you do before getting into data science and competing?
So I was a business consultant. I worked with the Boston Consulting Group. It's a great company. I spent there like 6 years, I think. Then they were generous enough to send me for an MBA program. I did my MBA program with INSEAD in Singapore. And that was also one of the best things that happens to me in my entire life. This 1 year, when you come back to university, you have some time to think, you have some time to reflect on what is it that you actually would like to do with your life. You have some time to search. So I'm a huge evangelist of MBA, of having a gap year to kind of reflect on what you would like to do, because actually it was during my MBA program when I discovered machine learning, when I wrote my first line of code, and this is how it started.
So then going from MBA, you started working as a data scientist at at BCG, or you went somewhere else?
I went back to BCG Gamma, because all of the big consulting companies are realizing that AI is going to change the world. So they are making separate companies purely focused on AI. And BCG has BCG Gamma, also a great company led by fantastic people. Sylvain Duranton is the boss there. He's a great guy, amazing guy. And so yeah, they realized the importance of AI, and they also opened an office in Warsaw, and they invited me to this office. And I was, for a short period of time, I was leading this office in Warsaw.
Wow! All right, that's.
And then consulting is, as I mentioned, is a great place to be. But after some time, you will just like to try something different. And then I went to NetSprint. NetSprint is one of the largest ecosystems, data ecosystems in Poland. It's also a great company with a fantastic management and leadership team. And then I went there to be a chief data scientist. And the major use cases that we were developing with NetSprint were predicting the behavior of internet users based on their past history. And this past history was stored in cookies. So that was prior to GDPR in Europe, which
Changed the situation a bit.
We changed completely the situation. But yeah, we were doing the predictive modeling, very interesting modeling. So for example, what we did, we developed a system with embedding for internet websites. So for example, websites visited by similar people were close to each other in embedding space.
Oh, got it.
And based on this system and this embedding of websites, we use it to predict, for example, if you are male or female, based on the websites that you are visiting. It is actually a very valuable information to advertisers, because then we could attach to every cookie the tag male, female, and then we could kind of sell it.
Personalize the messaging, or personalize the ad.
Yeah. Then I moved to, after NetSprint, after GDPR, the situation changed a lot, and I moved to Deepsense, where I am now, and I'm a director of customer analytics, doing projects related to customers.
So talking about that, what's interesting to me is how does your average day look like? As a chief of customer analytics now, or before at NetSprint as a chief data scientist. How does it look? And also on that note, does it change? Is it different from what you had expected it to be before? Before going to the chief role and being a data science contributor?
One big challenge that every manager has to deal with is amount of time he spends on coding, and amount of time he spends on managing the people. So it is very easy to fall into a role of organizer and facilitator, because you have your team to do your work for you.
Yeah.
At the same time, it is highly unsatisfactory to do just emailing and stand-ups and status meetings and scheduling. No. So, for example, what drives me most in my work is actually problem solving, and this problem solving is most attractive when I can also participate in coding. So that is one big challenge that I know is not only important for myself, but whenever I talk to people who grow up being like good programmers and developers or scientists, and they start leading teams, this is a huge challenge that they have. How much time to devote to their own work, their own research, coding, whatever it may be, compared to managing teams. I was fortunate enough because at Deepsense, we have really a great team of people. And these people, they require very little detailed management. We meet often to discuss objectives. We meet often to discuss the coordinate between team members, but they require very little supervision. Once the objective is set, they really use all the means necessary to realize that objective. So that is one great thing about working with Deepsense team, that they management time is very efficient, I would say.
So if you were to divide your divide your day, there would be some meetings with the management, meetings with the team, the dev team, and then contributing. How would you divide that?
So I would say like 20-30% is formulating the problem with the client and getting client's feedback. Another 30% is working with the team, and another 40% is my own coding and my own work.
Nice. No, I think it takes some conscious effort to get to 40% there, right?
It does. It can very quickly drop to 5 to 10%, and then you become unhappy as a coder, and then nothing good happens. So yeah, it requires some discipline, basically, in the way you organize your meetings, your stand-ups, in the way you talk to your clients.
And anything there is entirely different from what you had expected it to be, before getting into that managerial role.
I would say it is always surprising, actually, how much can go wrong by the lack of coordination between various parts realizing the same project. So, for example, once we were doing a demand forecasting model for an e-commerce website, and our features were based on customer early reactions to the product on the website. And then the design of the website was changed, but we didn't know about it. So our features started to mean something entirely different than before. And our predictions went wild for a very short period of time until we realized what happened. So it always amazes me by how little things and even very little lack of coordination can lead to shocking results in this modeling world.
And any tips on how to make that better? How you cope with that?
So, for example, I always try to have entire team in one room. I know it's sometimes difficult if the team grows larger, but I always try to have them all in one room, because then actually the coordination is much easier. Of course, there is some additional effect of too much discussion, and sometimes our working day basically transitions into constant meeting, which is also not good. But if I have to pick between the two, so the lack of coordination and constant meeting, I choose constant meeting.
No, that's it's also interesting in like you have a lot of teams now that are distributed, with some parts of the team working, say, in the US, some in Europe or Asia. So I think I think there's got to be some additional tricks that you need to do then. But I see your point. So on that note, are there any skills that you feel are extremely important to to their role as a leader of a data science team?
So I think there are a couple. I think the most important skill is actually knowing where to put focus and where to devote your time in the machine learning project. So actually the places where the largest value is to be harvested when done right, and the places where there are the largest sources of problems if they are done wrong. So I would say there are a couple of places like that. For example, the problem formulation is one of the key things that a machine learning team leader or a chief data scientist should know how to do. So it requires experience, basically, because it means that you should be able to know intuitively what kind of technology to use to what kind of task. So, for example, let's say we have a project of the personalization of website content on e-commerce. So, for example, recommendations. One approach could be to use like a traditional, let's say, classification, for example, approach. And the other one could be to use contextual bandits, so from reinforcement learning. And the choice of this technology at the very beginning has a huge impact on what kind of problems and what kind of issues you are going to be dealing later on. So machine learning, the chief data scientist should really know very well, or at least should know intuitively which approaches to try. That could be a couple of approaches, but just to narrow down in the very beginning which technologies are suitable for a given problem. So that is in the very beginning, I would say, easily one of the most important tasks. Then, of course, like on any project, you can devote your time to, or any machine learning project, you can devote your time to finding the best algorithm, looking for more data, and feature engineering. So, and again, it comes from experience. Data almost always, so new data, new good quality data almost always has more impact on your results than using different algorithms. So I remember couple years back, there was this bank in Poland that started using, as the first bank in Poland, started using the transactional data from the largest e-commerce website in Poland to give a credit scoring for young entrepreneurs. And this transactional data is typically very valuable data. And they had huge success with it. Why? Because addition of new data, competition is not using. They were able to price the risk segments that no other bank was able to price before. So they were the only one willing to extend loans to these guys. And they were precise in risk estimation. So adding new data, looking for sources of new data, and actually even talking to potential partners in giving you data is also a role of a good, of performing data scientist, in particular chief data scientist, because typically these conversations are, let's say, on a strategic level because they involve cooperation, sharing data and this stuff. So this is also, I would say, a very valuable thing to do. Then operationally, I focus a lot on feature engineering for the same reason. Extracting information from data more important than choosing algorithm or choosing hyperparameters. Of course, choosing algorithm and hyperparameters is also important, but rarely I have seen a big impact from these two sources. And then the last point that I think the data science community underestimates a lot, but actually applied, the people who actually apply their models to the reality and to the real life, they actually appreciate this aspect a lot, is the non-stationarity. So non-stationarity is when something fundamental changes in the process of data generation. And your models, and you need to make sure that your models are kind of resilient to that. I will give you one example. I had a very good discussion with the boss of the consumer lending area of one of the largest Polish banks. And he was explaining to me why he's using linear regression instead of light GBM, for example. So he told me that, because, first of all, imagine the position this guy is in. So he's training a model, and he's putting this model into production, meaning that this model decides who gets a loan and who does not.
Sure.
So this guy is making a multi-million $1 decision, and he will know the results only after half year or 1 year, when people start having problems with repaying the loan. So he has very late feedback, and he needs to make a decision now. And under such circumstances, what is very desirable for machine learning models is the vulnerability to sudden changes in the economy. So he told me that if something sudden or something big changes in the economy, he pretty much feels how the linear regression model will behave. But he does not have the same comfort with light GBM model. And I thought, I did not appreciate his comment until I ran into the same situation. So lately we are doing a lot of modeling in the non-stationary data environment. And we are doing all those tricks to kind of stabilize the outcomes. So, for example, these 20 models is one way to do that. But also having simpler models like linear regression is also one way to do that. So I would say this aspect of how your solution will behave if something changes in the data generation process, which is in the context of socio-economic domain, all the time, basically, because this is real life. This is very important and often not very well appreciated in the data science community, I feel. But I feel that is also the kind of knowledge that you get after at least a couple of years doing real life modeling and also having some failures on your back. Only then you realize the gravity of this matter.
Any particular failure you'd like to share that you remember and that drives you forward?
So actually this the one example that I mentioned before, the change in the website design, that suddenly, and this is like a great example of non-stationarity, because suddenly your features mean something different and your models are still doing the predictions. So this is in other words one of the curses of machine learning, that our models tend to fail silently, meaning that they are still doing the predictions. Everything seems okay, but the values of the predictions are very, very weird. So that was a great example of non-stationarity. Another example that I always give to students is hyperinflation. Imagine doing the credit risk model in the hyperinflation environment. Typically, one of the most important features in credit risk model is the income. Is personal income. But if you train a model 2 months ago and you have hyperinflation, basically at least half of your model, for example, is dead, because no one is falling into lower brackets of the income because there's hyperinflation. And of course, inflation is the phenomenon that we all experience. So all of the models that are basically deployed in real life, they need to be resilient to these conditions.
You're saying resilient. I've seen some folks deal with that by retraining, by having those models retrain.
That's one of
on a constant basis, and the other one, which I actually haven't seen, but I've heard people do to deal with that, is online learning, where instead of retraining every other day, I'm just gonna learn on every new observation that I have a label for. Have you seen examples, and do you have what's your experience with those approaches? Do they only seem like they solve stuff, or they make things better, but they don't necessarily make things good?
I would say the last statement is exactly correct, meaning that they mitigate. Of course, they mitigate the effect of non-stationarity, but they don't eliminate it. So if you train your model, let's say if you train your model every day, because that is a good practice to retrain daily, and then something really big changes. So even one day is still one sample, and one sample, depending on how long is your history used for training, let's say half a year. So this is only 1 out of 180 samples. And typically this is not big enough the rate of adjustment that you need in a business context. Of course, this helps. It never hurts to have a better frequency of retraining, but it is not everything.
So speaking about all those different aspects, different problems, you mentioned experience a lot. But is there, was there some outside of the experience on the job, some things that you did consciously to, to learn those things, and some things that you could recommend to the people listening to this?
So there are two sources of knowledge that I love. First one is competitions. And on competitions, you get to learn new techniques. So I Kaggle almost every day. I try to find some, even like 15, 30 minutes just to think about the problem, just to think how I'd approach it. And maybe just write one line of code. And it never stops with one line of code, but just to think that one line of code is enough. And then very good blogs, industry blogs. And one blog that I could particularly recommend is Fast AI, run by Jeremy Howard. And the other one is newsletter run by Andrew Ng. It's called The Batch. So these two I read most often.
Yeah, so like those are to keep you informed with what is happening, and of course with Kaggle you just you get exposed to problems all the time. So like, but is there maybe something that you remember, some book or a particular piece of advice on resources, or just thinking about the problem for people just that could learn those things that you mentioned?
In terms of books, I think there is one very good book. Let me check it online. What is precisely the title? So that it's called "The Elements of Statistical Learning" by Friedman, Hasty, and Tibshani. It's really a very good book. Other than that, I would say the best experience comes from real life projects, meaning that you do Kaggle, you learn a lot, but then you try to apply it in real life. And that is actually one area where I think there is still not enough opportunities that are exploited in the sense that take, for example, the amount of information that is there on the internet and what you can do just by scraping this information, analyzing it, and kind of giving some insights about the world around us. So there is actually one big branch of companies and startups that are doing exactly this. And recently, Blue Dot AI, I think it was, who was able to issue a warning against the Wuhan virus on 10th December 2019, so much earlier than everyone else. So this is the area where you need to connect, but this is very easy. You need to connect your models to data around you, and by automated analysis of the data, you can give a really interesting insights.
Speaking about those insights, I remember, and that's something, especially since you're you're working on those problems every day, just to learn. Something that stuck in my head from our previous discussion was this something you said where you not necessarily want to solve a problem in the most most technically advanced way, but you always want to be answering a good question. Could you unpack that? Because I think that's extremely valuable and something that people should hear about.
So that is the reason why it is actually possible to come from the industry and learn coding at the age of 29 and then be chief of technical team. Because so I admit my code probably is very clumsy, but at least I try to always focus on the question that I'm answering. So basically that I spend zero time on irrelevant issues. And that is something that actually can give you a huge advantage as a data scientist or a data or machine learning engineer, is actually not so much the technical excellence of your code. This is very important. But I come from a different side, and I see that actually knowing where is the value in the problem. So meaning that the stuff that I talked before, spending some time on thinking what technology to apply, spending some time on thinking what data to have, some time on data engineering, then on making sure your models are resilient to non-stationarity. If you do that, you always answer the right question. And even if your code is clumsy or not such technically great, there is still enormous value coming up from your work. So this is actually a big hope for people transiting from industry to coding and to machine learning, because this is the skill that is very natural to people who are used to solving big business problems.
I think it's actually good advice for for anyone working in the field to first think about what you want to do and then do it. I know myself, I often jump into doing before thinking, just because I think I know a solution or something that
and I fully get it. You almost see the code already in your head, right? You just need to start right. Yeah, I know. It's the same.
Any tips there as to how to sort the things that you want to work on and how to think about those problems? Do you have a checklist that is stuck just over your laptop that you go over? Let's start with the data, then start with the model or something like that, or
having good process, because I believe that's what you are referring to. So having a good process of data analysis and modeling is actually very important, because machine learning and AI is a very young field. So there is not so many, like established best practices that are taught at university or in any book. So actually, and again, it comes with experience, but I try to follow a very structured process. And of course, we deviate from this process all the time. But at least by following the process, I am sure that all the important elements are covered. And actually, for example, when I was doing, it is important in real life, but it's also important in the competitions. So when you do, for example, when you do a model that you want to win the competition with, it's actually very important to at least touch on all the sources of potential value, meaning that data, feature engineering, hyperparameter optimization, then ensembling, then thinking very carefully about the validation. So then if you follow all these steps and you tap, let's say, on 80% of value coming from all sources, then you have a really robust solution. Because for myself, I tend to focus on things that I like. And I think this is very natural for all of us.
everyone.
So I like, for everyone, so I like a lot the feature engineering part. And I think that is, you remember the competition in 2018, the home credit risk modeling competition. That is, I think, where we lost the first place, because we focused a lot on feature engineering. We had great features, but we completely forgot about, for example, ensembling, which is a huge source of value. So that's why I try to follow a very, very strict process, just to make sure that I exploit all the possible sources of value in the project.
In a super high level, of course, don't let on your secret sauce, but in a super high level, what's the process? Let's say you're starting a new project this minute.
So to me, my best ideas come when I am having a walk in the park with my wife. So that is very high level, I would say.
And difficult to reproduce.
I mean, yeah, for some people. But and don't tell this to my wife, but she already knows that I tend to think about machine learning when we spend time together, and she likes it too. So I remember this one idea when sometimes you just need to take a step back and do something completely different. Go to the park, I don't know, go have a beer, talk to your friends, and then the best ideas come. This is how it works with me. Maybe a little less high level. A little suggestion is to basically. So my running coach, he tells me that if you want to get in shape, you need to be patient. So always your level comes with patience. And that is also the same in data science. You need to spend a certain time on coding. You need to have a certain number of failures on your back to learn, then to absorb it, and then to become better. So if I talk to a beginner data scientist and they ask me about Kaggle, I always tell them, forget about the results, focus on consistency and focus on learning and focus on fun, because this is the most important. And if you spend sufficient amount of time, then the results will come.
No, I think, I get it. And also this process could be a bit different for different people. So it should, be refined and over time sort of, improve with every batch of new knowledge, I think. Speaking about new knowledge, something I am really interested in is what are the things that you're learning right now, and things that you are particularly interested in, looking, let's say, a year into the future in ML.
So my research right now is focusing on two domains. First one is reinforcement learning. This is a technology that I believe has a huge potential going forward, and I don't think I have explored it enough in the past. So I focus a lot on reinforcement learning, and the other part is actually the research I'm doing at INSAT is about unconscious biases and how these biases impact our decisions. And what is very interesting to me, because I'm both in the field of machine learning and at INSAT in the field of human learning, is actually analyzing and seeing what are the similarities in the process of learning between human and the machine. And some of the conclusions that we have here are really interesting. For example, I think now the big topic is diversity and inclusiveness in organizations, right? So I think actually machines are much more advanced in diversity and inclusiveness than human are. Why is that? So if you recall any Kaggle competition, it is never a single model that wins. It is always a team of diverse models, right? And also the examples I gave you from a production real life environment, when it is very good to have a diverse team of models because then the combined result is much better. So for any machine learning engineer, it is obvious that you should have diverse models in your modeling stack. While for humans, it is not so obvious. And one key difference why that is the case is because in machine learning and AI world, we always analyze the results of the team together. And in the human setting, you are never analyzing the performance of the team together. You are always analyzing individual performance. You have individual performance bonuses. And actually, having the best team of 4 is a very different task from having best 4 individuals. It's a completely different stuff. And it is only because we cannot measure the team effects as such, is that we end up in an environment when we consider, in every recruitment process, we consider this particular person typically not in the context of a broader team, but rather as a sole source of value, a single source of value. And I think that is a...
Yeah, and that's how we measure, right? Oh, sorry.
That's how we measure. Exactly. That's how we measure. We feel because of, okay, so what happens? We have, you say you have a board of a very large company. You have 4 guys, white males between 40 and 50 after Harvard. Okay, you add additional 5th guy who is just the same. He was much better than all the other candidates in the field for a single position. But if you think about the team, it would be much more beneficial if someone with a diverse background was sitting on this team. So this is very obvious to everyone in AI, in machine learning industry, but this is very difficult to grasp for humans because we cannot measure.
Yeah, it's difficult to set up this simulation where a new person would be added and the performance would be gauged in a new team rather than that particular person's performance.
Exactly. And we don't have a good solution for it right now. But I think it is a good question to ask. It is a good issue to spend some time on because this is just very interesting.
No, I agree. I agree. Definitely. So I have, sort of on a bit different topic. I have a question I really want to ask you and share with the listeners and readers. Basically, what would you advise, people that are at a position, say regular, regular data scientist or a junior or even a senior person, and those who want to progress to achieve data scientist or lead or head of AI, what would be the core skills that you think people should focus on, and what would you advise them to do to sort of progress in their careers?
So I think first, absolutely the most important stuff is always do things that you like and that you love, because it is very easy to be successful if you are doing stuff that you like, period. And which means that some senior and very technical guys, if they like coding, they should just do coding, and because they will lead the team naturally with their coding skills. The guys who like to talk to other people and get diverse sources of data, they should do that because they will bring a lot of value to the team and the team will follow. So I think it's always because it is one area where I think companies have not yet sorted it out, how to reconcile the need for a very good programming skills with the need to manage the people when you progress in your career, right? So I think it is still an area that people need to figure out for themselves. So I always advise, do what you like, do it very, very well, and your lead will come from this. This should be the core. Because, all the trainings on management or trainings on how to manage your team or trainings how to manage your time, they are only very secondary. Your lead and your presence as a chief data scientist or a team leader should naturally come from your passion because it is the best. And it is very true, and people always follow people who are true in what they do. So I think that is the most important advice. Of course, there are a set of technical steps that you can take. As I mentioned, they should always be related to the sources of value in machine learning project. So so you should advance your skills in problem framing, in different sources of data and acquisition of those sources of data, and in non-stationarity. And and of course in team management and mentoring your younger colleagues and giving them advice. And if you do that, you will become a leader naturally. And I need to mention that typically developers, including myself, we tend to focus a lot on coding only. No life apart from coding. So only advancing technical skills. And I think this is the place where people can go. Of course, if they like it, they should, but they can go too far, meaning that after some point, advancing your technical skills will not get you closer to making a next step in your career. Of course, if you want to become a data scientist, chief data scientist, because for some positions, the higher the technical skill level, the better. So it always depends. Yeah.
No, but it's an interesting one where instead of focusing on necessarily focusing on like the weaknesses or focusing on, let's say, the core I don't know, skill set, you'd rather focus on the things that you can naturally excel at, because you're gonna have more motivation to get deeper, etc., right? Something like that.
Yes, exactly. And as you mentioned, it is not so typically people tell you focus on your skills and focus. It could be good, but I think like the core of your leadership should come from the things that you are passionate about.
Although I see this approach where instead of instead of focusing on the weaknesses, you want to focus on the strong sides, just to to have this top 1% skill at some maybe one or two or three things where then you connect it and you actually end up being 1% to the third of population in this particular combination of skills. So I like that. Anything that you would like to leave our listeners with, a thought that you would like to share at the end?
I think AI so far, and this is like a very broad reflection, AI so far has had a tremendous impact on technology, computer vision, translation, natural language processing, but still very little impact on the real life. So I would imagine, and I would encourage such applications, and I believe education and healthcare are those two applications where the impact could be the largest. I encourage people to work there and think how AI and machine learning could change the situation there, because I like to think that machine learning and AI is the next big thing in what will happen to the society, but I have not seen it so far. I have seen it in technology, but technology for technology is not interesting. It should change our lives. So I encourage a lot of thinking on application, on real life application, on how can we make it all better with all this fantastic seemingly technology.
Getting that problem framing and put it into good use in real life.
Exactly.
Thank you so much, Pawel, for this awesome interview. Great time speaking to you. Always interesting things to learn. Thanks a lot.
Thank you so much. Thank you. It was great talking to you.
Okay, that's it for today. Thank you so much for listening, and till next time on Machine Learning That Works, a podcast hosted by Neptune AI.